Hi, Algebra 2. Just wanted to check in with you today, following up on the work that we did with writing models using linear functions. We did that Desmos activity today. I know those numbers were really big, and I think that got in the way of understanding a little bit. And then I think there's also some work we need to do to get our hands and minds around the idea of point slope form. So after we finished with Desmos and took a break, we jumped in on the quizzes, all right, and had a chance to write some point slope and slope intercept form equations. So we just want to remind ourselves that point slope form sets up like this: y minus y1 equals m times x minus x1. So your m is your slope, and you've got a point that's going to be x1, y1. So if you're asked to write an equation and the information you're given is the slope and one point that's not an intercept, point slope form is a quick and easy way to write a perfectly legitimate linear equation with just that information that you have. Okay? For slope intercept form, you recall that m is the slope and b, the constant at the end, is your y-intercept. If you don't know the intercept, you can't really jump right in and write the equation in this form first. You can write it in point slope form and then over to slope intercept if it comes to that. And the third thing that happens, we'll see an example in a bit, is that we're given 2 points and asked to write an equation. So from 2 points, we can get a slope, okay? And if we have a slope and we know 1 point, we can write a point slope equation. We've got 2 points, so we've got our pick, right? So these are the first things we want to think about, is this is the form of these equations, what they look like. So real quick, let's go ahead and take a look at one of the items that came from quizzes today. So let's write an equation of a line that has a slope of 5/4, and it goes through the point -4, -3. So we know a slope, we know a point, that screams point slope form. So let's write it. Y minus y1 equals m times x minus x1. Mr. Dahl, do I have to write the formula every time? I don't want to write that much. It takes too long. I know. Okay, I know. But until you get in the habit of understanding where each of these values goes inside of that form, inside of the equation, it helps to have the format written so you can see where they go. So y minus y1, which is -3. Okay. Keep in mind, we're subtracting a -3. So I'm going to put my -3 in parentheses, equals m, the slope number, 5/4, and then x minus x1, which is -4. Okay. So now that we've inserted all our values, let's simplify. So y minus -3, remember that's like saying y plus 3. You subtract anything, it's the same as adding the opposite. 5/4, and then x minus -4, so x plus 4. Right? So now, this is a perfectly fine linear equation, point slope form. You could leave it like this. If it's asked for in point slope form, you're good to go. If you remember the quizzes from today, what you were asked for was to give it in slope intercept form. All four distractors, all the ABCD options, were all in slope intercept. So what do we do with that? Well, look what you have here. You've got a number times a quantity in parentheses, right? Let's do distributive property. So 5/4 times x, and then 5/4 times 4. 5 times 4 is 20 divided by 4. That's 5. Right? So in this case, we don't care if there's a fraction as our slope number. Right? That happens all the time. So we're used to it. We've got a constant for our intercept, and then over here, y plus 3. So this is pretty simple to simplify. If I need to solve for y, I'm going to subtract 3 on both sides, right? So y equals 5/4 x, 5 minus 3, that's 2. So these two equations are exactly equal to one another, right? Exact same thing. And if you go back over into your quizzes and you took a look at the options you were given, y equals 5/4 x plus 2, that was one of your options. Let's take a look at another one. We said there was an example where we might run into this case where I'm given 2 points. So -4, -2, and -3, 5. Awesome. So let's see what happens with that. So the first thing I need is a slope. So y2 minus y1 over x2 minus x1. Let's plug in some values. 5 minus negative 2 and negative 3 minus negative 4. Okay, 5 minus negative 2 is like saying 5 plus 2. That's 7. Negative 3 minus negative 4. That's like saying negative 3 plus 4. That's 1. So this seems like it has a slope of 7 over 1. And if we think about where these 2 points are, negative 4, negative 3 are right next to each other on the x-axis. This point is 5. This one's negative 2. Yeah, a slope of 7 makes sense there. Okay, so we have a slope number of 7. So now y minus y1 equals m times x minus x1. What are you doing, Mr. Dahl? Well, now that we have a slope and we have 2 points, I can pick either one and use that for my point slope form. So let's use this guy right here. Y minus negative 2 equals 7 times x minus negative 4. So y plus 2 equals 7x. I'm going to skip a step here. Y plus 2 equals 7x plus 28. So y equals 7x plus 26. And if we go back and we check our possible answers, that was the one right there. All right. So this idea of using point slope form to be able to write an equation, and then if you need to convert over slope intercept form, is something that is right in the wheelhouse for you guys. I did want to do one other thing with you guys, and I wanted to jump over and take a look back at the work that you guys did in the Desmos activity today. And we were using some data points to try to create a model of data, and then taking that model and using it to make some predictions about what might happen in some of the years that weren't included in those original data points. Right? Definitely is a standard and a skill that is asked of you guys in Algebra 1 and in Algebra 2. And in the course of setting this up, I had you guys write some equations, interpret a graph, try and read off a linear function and get a sense of slope and y-intercept and so forth. So let's jump back, and I'm just going to grab one of these just at random. And so here was the line that this person created, a line of best fit, and that one's pretty solid. Okay, pretty solid. It comes in a little bit above this point, a little bit below this one, a little bit below here, and above this one. So I think, all in all, it's a good fit. And then these are the actual enrollment figures for these 5 years. If I scroll down, we'll get a look at this person's figures that they used. Right. So they had a slope of 11,000 and a y-intercept of 235,000. So here's where things maybe went a little sideways with some of the work that we did. So if we do point slope form, we have to take a point that we're reasonably sure this line goes through. And this one is probably our best bet right here. So if I was going to take a point, I would take 3, 2, 6, 8, 3, 5, 7. All right, so if we want to put this in point slope form, let's take a look at what happened. Y minus 268, 357 equals 11,000 times x minus 3. So this is what I was looking for on that screen with the point slope form. Let's go ahead and convert this over to slope intercept form. Y minus 268, 357 equals 11,000 x minus 33,000. Okay. So if I add 268, 357 on both sides, and I can see how these big numbers get a little odd to work with. Y equals 11,000 x minus, So this minus 33,000, 235,357. Let's say you just took these two figures and you wanted to write a slope-intercept form. So 11,000x plus 235,000. Those two are pretty close. But what if you picked a different point? I think one of the things maybe you could see if we jump back is that, for instance, this last point was a little bit below the line. If we did, y minus 308,783 and tried to convert that over into point slope form, we wouldn't get anything that looks like this. And this was where some of the difference came in your estimates from your model and then the actual figures as well. So I was just hoping to kind of go back over that with you guys, let you take a look at that and kind of see where some of those numbers came from.